today is talk about model deployment. And what we're going to do is I'm going to first talk about it at a very high level, make sure we kind of understand some of the fundamentals. And then we'll go into using some kind of notebooks that are already set up, where essentially all you have to do is just hit the play button. And we can walk through actually deploying some models in some various different circumstances. Now, to get the notebooks, it's important to be able to go to this GitHub. I think I put it in the chat, but you'll want to go to that GitHub there. And there's Google Colab notebooks that you can use directly on Google Colab. And so that way you can run the notebooks on Google's infrastructure and you don't have to worry about setting up your local Python environment to do that. And then part of one of the things we're going to do at the end for fun is add a monitoring agent. And for that, you need a DataRobot account. So if you have time, you can sign up for that. But otherwise, all this stuff, if you miss it today, it'll still be there tomorrow, next week, for you to go to as well. So as we go through this. So we're going to just start talking a little bit about deployment overall. And then we're going to use this open source tool Drum to actually deploy a model. And we want to just show you how easy it is to kind of deploy a model, as well as if you want to use different types of machine learning frameworks, how easy it is to swap among them. That's going to be the bulk of it. Then I think at the end, we'll see how times goes. We can talk about monitoring, as well as some advanced use cases for it. The example we're going to go today is pretty simple because we want everybody to kind of get a good feel for how Drum works. Okay. So let me know if there's any questions. Otherwise, let me jump into it a little bit. Now, I know there's quite a few people on the call that, for example, that were either new to machine learning or were really interested in deployment. And deployment is something that's very undervalued among most data scientists. But the reality is your machine learning model really only gets value, is only useful to the organization when it's actually being deployed. Because when it's deployed, that's when you can use it for new data. That's when you just stop experimenting with it on your laptop, but actually can put it out there to help you make better decisions. So, and the models could be from, right, we heard of very many, could be in a manufacturing plant where you're doing some type of thing. It could be a churn model for a magazine publisher. But all of those, you require getting your model deployed to actually use it to make new decisions and generate the value. Now, I think most of you probably have realized if you spend your time in the data science world, tons of literature on algorithms, right? You can read forever on different types of algorithms, how to build them, how to tune them. The vast majority of resources focus on that. And I'm not going to undervalue it. It's an important piece of that. But one of the things that's happening now is as we see data science teams struggling with getting their models deployed, as well as all the challenges to getting models deployed, because it's not only data science, it's also IT. Nowadays, there's a lot of kind of specialization that's coming around deployment and kind of specialization in terms of roles, but also an increased focus on deployment is important and we need to build resources for it. So for some of you thinking about getting into data science, kind of some of the roles are often like an ML engineer that focuses on a hybrid of data science and IT to help work and get those models deployed. So again, it's another one that requires a wide variety of skills, but for those of you kind of thinking about data science, it's also, and if you have an IT background, it's a great fit and it's heavily in demand, as probably the other practicing data scientists can vouch on. So when we talk about how do we deploy this model, right? Many data scientists will use tools, R, Python, Spark, whatever, and we'll build some local model. And often we start by just building a model on our laptop, maybe some server. And that model there is capable of getting new data and making predictions. But models just don't generate value by themselves. Typically, you need to connect them to some type of application. So you can think about it, for example, if you have your model for predicting loans. Well, we also want to tie it to a web app, someplace where somebody is inputting in that data and then asking for the prediction. And so this is one of the questions when it gets to when we want to deploy this model. One thing we can do is just take our model, put it right next to the app, put them together and deploy them all as one object. And that's a very simple model. You see it all the time. If you're, for example, a Python person, you might, for example, build a simple proof of concept app using Dash or Streamlit, and your model and your app are sitting together in one code base. If you're an R user, you might use something like Shiny. This type of design pattern makes it very quick and easy to get your model in there. But here's the thing. If you put your model and app together in one place, they're sharing that code base, which if you're doing some app that takes a lot of web resources, web deployment, all of a sudden now you've made an app, you've made your code base really wide because you have to have your entire code base for your ML as well as whatever your other application is. So that's the downside of the simplicity is if you want to go update that app now, or if you want to update your model, you're updating the entire app. And so then it becomes troublesome to continually kind of update those things. And so kind of this is my nice visualization is you get everything in one, but over time that gets really complex because it becomes hard to maintain because you get more and more features of your app's going to have features, your model's going to need updating, and every time you got to push it all together. So this type of deployment pattern is only used typically for very simple kind of proof of concept things. Most people kind of, especially nowadays, use a very different pattern where instead what we do is we build our machine learning model and then we wrap an API server around it. And so what this means now is our application that's using the model is distinct from the model. And what this means is if I need to update the model, it's really easy to update the model. I don't have to take my app down to do it. Now, what the API server does with kind of I used a REST API example here is now we have a pathway for communication. So the app will say, hey, Beth just showed up. I need a score for her. We'll send that information through over to the actual model API server. The model will read that data and then output a prediction back to the app. And then the app will be like, oh, this is the score for Beth. And so this is how that transaction is often occurred, is we use some type of kind of, communication protocol to communicate between the app and the model and get the predictions back like that. So let me take a pause there, kind of make sure everybody's with me so far. All right. I'm looking for head shaking. Okay, hopefully. And so this is kind of really the common deployment pattern, and we see it all over data science. And I think people can maybe disagree, but I think it's the prevailing method nowadays for using your data science models is to wrap them with some type of API service. Now, if we look at what is the most popular way of doing it, Flask is still out there. It's welcome to 2016 because this article was in 2016. But unfortunately, over the last 4 or 5 years, we really haven't matured very much in data science for figuring out a better way to serve our models. This is still, I was talking to an insurance company last week. This is exactly how they were using a combination of Flask to get that API server, and then they would use a Docker container to containerize it. So I still see this as a very kind of heavy pattern. The problem with this approach of using Flask is really a web framework, and it's not attuned to the needs of ML development and ML deployment. Every time you do this, you got to create everything from scratch. There's a lot of custom coding that you have to do. It's not built for kind of doing kind of the unit testing. If you want to plug in a different type of model, if you want to change things, every time you have to go in and manually change stuff. So what often happens, and this is often the sentiment you'll get if you talk to lots of data scientists, is here's the thing. If you want to build a model and deploy it really quickly, it's easy to do, right? Anybody can, in an afternoon that knows Python or R, can do that exact pattern that I showed you and get that model with an API working in off an API. But here's the tricky part. That's easy for one model. Now the problem is what happens if you have tens, hundreds of models? What happens if all of a sudden you care about the latency, the reliability, the maintenance of these models? So that same insurance company I was talking to, there was one person and he had 4 models in production. They were all using kind of these Flask Docker containers. But of course, they're all done at 4 different points in time. So all 4 are slightly different. They're all 4 kind of different types of use cases. So the maintenance load for this person, you can see, is going to keep continually increasing as they do more and more, since each one is custom. Really what you want is something that's easily scalable, so you're not kind of having to custom tweak each one. Is this making sense so far? Okay. So the wish list here is, if we're thinking about this, is what we want in a modern deployment solution. I need to do my animations better. Is you want something that is reliable and fast. I mean, Flask is nice, but it's still kind of a bit old. There's newer technologies like uWSGI we'll talk about that are a little bit better. You also want something that works across different languages. So whether you're kind of like Python or R, or maybe you're a new person getting into data science and your data science class taught you PyTorch. So no matter what, you want to be able to work, you want your deployment solution to work across the languages. Because the other thing is most data science teams are multilingual. Most of them have people working in different languages on the team. Very few data science teams I see just say everybody has to use one approach or one model. Needs to be able to handle the diverse. And then finally, we want something that's easily repeatable and automated. One of the things I see is as organizations get better and better with machine learning, they're vastly kind of, the scale of the amount of models they put into production is almost kind of exponential. As you get good at it, you're starting to find more and more use cases. And the other thing is, when you first start, you might just use one machine learning model to solve one problem. But as you get better at this, you might discover that actually, you know what, if I use an ensemble of 10 models, I can actually get a bit of an improvement in performance. But now you have 10 more models to deploy and scale and manage. So this is one of the other pieces that goes along with that. So these are some of the things I think we should think about when we want to kind of think about a deployment solution. And what I want to do is, and what we're going to spend today is, we're going to kind of walk through using Drum, which is a deployment framework that's really built for machine learning. And part of it, as we'll see, is it auto detects, for example, different types of models. It's fully open source. It's Apache 2.0. You can go out, grab it, have it forever with that. If you want to install it, it's just a quick kind of pip install to install. So one of the questions that always comes up is, well, like, what's in it for you, Raj? Like, why are you doing this kind of open source thing? So I want to kind of just give you a little bit of the history of Drum, and then we'll jump into kind of using it. So this was originally developed for DataRobot's MLOps product. Our MLOps product works for lots of different frameworks, and it offers model monitoring, management, governance, all these other services on top of it. But what the development team wanted to do was just take the core infrastructure and just make that widely available. They just wanted to make sure it was robust, had many eyes on it, and open source does that. The nice thing is, for data scientists, it also now gives you an easy way to deploy your models. You don't need DataRobot or any connection to it to be able to deploy this stuff, as we'll go through this. All right. So almost ready for you, Tim. So what we're going to do here is just build a simple regression model. We'll use scikit. It's just pretty standard. And then we're going to go ahead and use the Drum tool to get that REST API endpoint. Then we can kind of use it, query simple apps with that. So this is kind of the mechanism, the mechanics of what we want to do. All right. You good? You ready, Tim? You can kind of take over, and let's see, is there any questions at this point? Oh, wow, lots of questions in this Slack.
Yeah, a lot of really great comments here. And like, so why don't we pause for a second? Because
yeah, I didn't realize that. Yeah.
I think Matt Havlett brought up Fast API. And so I was asking if anybody has heard of that before. Matt, I don't know if you'd be interested in sharing any of your experiences or thoughts with that. Definitely would be open for just.
Okay, so I am developing a website that's going to be a React-based app, JavaScript, and similar to what you were describing with the REST API, but I'm using civil engineering calculator programs instead of a machine learning model as the model per se that's being wrapped by the API. And after looking at a lot of different reviews, it looked like the Fast API was similar to using Flask, but it was built from the ground up with the uWSGI instead of just the WSGI, and handles the async much better and is much more performant than Flask is for API stuff. So I went through the hassle of the WSL on my development machine, because the Fast API only runs in Linux, unfortunately. But I'm learning that in Docker and a whole bunch of other useful stuff at once. So I was just curious if anyone had used it in place of Flask before.
Other than reading the docs, no.
Yeah, it's the modern version of Flask is kind of, I think, simply what I would say, right? Because it does use kind of uWSGI and a stronger architecture underneath like that. I think it's still, though, fairly kind of new for most data scientists, and it's starting to kind of gain a bit more traction. Does that make sense? Anybody else have different views, or?
Yeah, Robert mentioned it's refreshing to hear people putting an emphasis on productionizing things. So, and then Marcus said that it's you're touching on all of the difficult issues a maturing data science team is going to be facing. And I mean, and I've been in that position where I've been just like a two-man shop, just doing all of our deployments in nothing more than batch, right? We'd have like a cron job that would be scheduled to give on a given night of the week. And that was as far as we could get, because we were just kind of pinned down with resources. But yeah, that's yeah, absolutely.
Yeah.
Cool. Any other comments? Anything else anybody like to bring up? Or? I know everybody's just so anxious to get into some of this stuff. That's why nobody's talking, right? And I am going to be screen sharing, and so hopefully folks can see my screen. So really the point is, and yeah, like somebody mentioned this, right? It's really, I think it's really hard to take models and start making them actionable, right? So really thinking about how to put them into production, how to do so reliably and in a robust fashion. And so that's all what we're going to really try to highlight with what Drum is helping do. So a lot of the stuff that we're going to do really is not going to be a practical application. We're just going to be running stuff from notebooks, but it's really just sort of just to make some examples and show some of the value prop and some of the things that we can do from within Drum. And, but before we do that, I really want to kind of step back and highlight some of the stuff that Raj mentioned. And when it comes to Drum, it really comes down to one of the things I find most useful is it's the built-in model support. So when you spend a lot of time and you've been creating a lot of really great models on your laptop, your desktop, and you want to move them over into a production environment, being able to deploy them, really like, how are you going to do that? And then there's a handoff that has to happen. And so within Drum, it's one of those things where it just kind of shortens that handoff. And when I say that, it all comes down from the fact that there's a lot of built-in support contained within the Drum tool. And so right where I'm at right now is just on our DataRobot user model repository. And I'm just highlighting here what we have available, like right off the shelf. And so when I say that there's built-in model support, when you're going to execute Drum, you just have to point Drum at the location of your model artifacts. So if you've been training models in scikit-learn, XGBoost, Keras, if you have some PMMLs that came from somewhere, yeah, can be able to host those pretty easily and without a lot of work. And also be able to host, R models. I'm not much of an R programmer, but I think a pretty popular library is going to be Caret. And when you think about turning those into artifacts and hosting those up, that's something that Drum can certainly assist in. And there's a certain expectation in terms of the pattern that these models are going to follow, whether or not it's going to be the predict method that's going to be exposed or whatever. But in the instances when you have a model or artifacts that don't really subscribe to the simple pattern, we really do provide a pretty simple mechanism for you to write up some custom hooks that really let Drum know how to hook into your Python or your R model and be able to serve those up, right? And when we talk about custom hooks, it could be covering everything from how are you going to handle some pre-processing steps that wasn't handled in your model, but you need to do that before you expose data to the model, post-processing steps, or even if you want to get a little crazy and go complete wild mode and just really not have much of a structure involved at all in terms of the data you consume or the predictions that you provide. The hooks are going to be able to handle a lot of that for you. And last but not least, we do have some off-the-shelf support for some Java models. And when I say Java models, I'm really talking about DataRobot models or H2O models. So support built in for DataRobot models that can be exported as jars, open source H2O, by way of Pojos or Mojos. And we do provide some support for driverless AI models, where driverless AI models require licensing, so we don't really include those in any automated testings. We just provide the framework that we were able to suss out from the publicly available API. But yeah, you can host your driverless AI models with Drum as well. But so when we're going to go through this, we're going to focus primarily on this colab Drum model serving notebook. And so if you're going right from the GitHub repository, once you click into that, you should see an open in colab notebook or open in colab link. I'd encourage this being the way that we would go through this exercise. If you want to go through and do all of this locally, you can certainly follow along. I think the directions are pretty complete just with regard to the README here. But for our purposes, getting up and running from within that Drum model serving notebook, it's going to be probably the pretty quickest route. And so I'll stop here to see if anybody is having any issues or if there's any questions currently. And I'll take that as a no. So one of the things within Drum is that it's not only going to be a service that's going to help us go through and maybe deploy a model to an API. There's a lot of other utility that it can provide. That utility can come by way of performance testing of your model. That utility can come by way of a simple validation of your model. And right now, when you think about validating a model that you want to deploy, that validation is really a matter of like, are you going to be able to handle records that you're going to see? That could mean that we could do some simple checks for, can your model handle missing values? And I would imagine too that later, that there would be exposing tests, be able to handle, new levels in categorical variables and maybe some other tests that will become a part of this. But just for now, we're just handling missing value imputation in terms of the checks that we place on top of your model. And the other thing that we can do from within Drum is that while it's going to be pretty awesome to be able to deploy models to an API, we can certainly leverage this tool for batch scoring. So really just being able to run Drum, use batch scoring, and all while doing that, we can either leverage local resources for batch scoring, or we can do all of this by way of a Docker container where Drum can handle, as long as you can point Drum at an appropriate Docker file, it can spin up that Docker container, it can put your model within that container, and it can complete the entire batch scoring process. Or in most cases, what we would probably see are people, leveraging that Docker container to host the model, via an API. So we're not going to focus on the actual art of building a regression model. It's going to be a really, really simple random forest that we're going to do via scikit-learn. The main point here is that we are going to train a model with scikit-learn, and we're going to, write all of the artifact out to disk, and that's what we're going to be leveraging when we're going to be, leveraging Drum to be able to help us, leverage that model and make predictions with it. So as we're going to step through this, there's going to be a couple of obligatory clones and pip installs that are going to have to occur. So as you may have opened that notebook in Colab, we're just going to grab all of the items that go along with the repository. And from there, we're going to install all of the Colab requirements required to execute all of the remaining code. So this is going to be just installing DataRobot Drum, probably grab scikit-learn, extreme gradient boost, maybe a couple other libraries that we'll leverage throughout the rest of this. But they're all important in order to execute the code without any issue. So while this is going through the pip install, does anybody have any war stories or horror stories or victories that they'd like to share in terms of a deployment? I think those are always kind of fun to hear.
Sure. Yeah, this is Marcus. I got one.
Yeah, Marcus, please.
So the deployment basically, so I'm trying to word this so I don't divulge company secrets and everything like that. But basically the advertisement of what the production data would look like did not match the test and training data that we were provided as a static CSV. The whole project was to predict quality in manufacturing before it begins. And the advertisement was a reservation system for batches of raw materials to be selected was available. So we would know what raw materials would be used. So we trained on history, we trained on 5 years of history, made a model, successful model, could predict quality, great. Implemented production, and we do not know what raw materials will be used before manufacturing begins. The reservation system that was advertised was not actually being used by the process engineers. So,
oh wow,
8 months of work went out the window, and we gotta wait 3 months for them to get that reservation system in place.
And this isn't unusual, you know, these kinds of problems. I think often there's a big difference between the data that you see in production versus what's given to you to train. There was actually a recent paper from one of the Google on under specification that talks all about this, how distributions often change between the data that you train it on in production, and it causes lots of problems when we start talking about managing models and monitoring models, because the first day you're starting to monitor the model, you notice that the performance drops off the cliff. So no, I'm with you.
Yeah.
Yes, very much so.
I feel your pain.
Or people change variable names. And,
appreciate it.
Yeah.
I would say exactly what you said previously, that dealing with missing values and dealing with categorical variables that changed to something that shouldn't have happened, but happened.
Yeah. Very common. Cool. Thanks for sharing, guys. Thank you. So yeah, everybody should be at about this point right now. There's about 5 or 6 lines of code where we'll go through, we'll create our model, and we'll write that model to disk. So this is very not exciting whatsoever. The exciting part is going to be when we're going to start to act on this model leveraging Drum. And I'm going to say it's a very low code solution, right? When we want to start being able to do whatever it is we want to do with this model. You know, Rajiv sort of spoke to it earlier, is the typical pattern was that you would take your model, you'd instantiate it within the application. So you'd have to leverage that, and you'd have to do some coding, you'd have to do a lot of lifting and maybe some gymnastics or whatever to sort of orchestrate that. But exactly what we want to highlight is that as we're going to go through and highlight the utilities of Drum, is that all we're going to do, execute some command line where we're going to point Drum at the appropriate place. And we'll start out just by getting into Drum and looking at batch scoring within Drum. So Drum on its own, and Rajiv spoke to this quite a bit. There's a lot of functionality that can be had within this. It's going to help you score data. It can actually help you fit models. And I provided an example of that within that GitHub repository. If you take a look at the brief tour of Drum. And then fit, it just, you have to subscribe to the pattern that we're looking for in terms of being able to let Drum, you know, run the fit mechanisms. But being able to run performance testing on your model, you know, understanding how quickly can it score, like, you know, 1 MB, 10 MB, 50 MB, 100 MB worth of data, how much memory does it consume, et cetera, as well as running through simple validation, hosting your model on a prediction server. And we're not going to get too far away from Flask for today's purposes, but you know, just by altering the arguments we pass to Drum and making sure that we would have the back end, the infrastructure and the back end in place, we can easily go from Flask and leverage NGINX and uWSGI to be able to host our model. And the benefit there, right, is that we're able to, you know, handle a lot more requests, you know, leverage concurrency when we're going to be hosting those models and making predictions with them. The new functionality is really just to create a template, nothing more than that. So I might create a new model, and then I might leverage Drum to fit a model and have it write all the contents to where the new template was created. And then last but not least is push. So if you get to the point where you actually want to leverage DataRobot for any of the operationalizing of the model, that's certainly going to be a component to this as well. But within this notebook, we're going to focus all on score and all on server. Okay, because I think that batch scoring does have its place, right? Batch scoring, being able to run your job, being able to take out a flat file and being able to do with it whatever you need. It still has its place. It's probably still a pretty common pattern in how people are scoring data, I would say. And within this, all I'm going to be doing is calling out to the command line to execute drum. I'm going to execute the scoring method, and I need to point drum at the code folder. So that code folder, once we've pulled that in, that's going to be located in that source custom model folder. So that's where I have that pickle sitting, and I do have a custom.py file available where I can write additional hooks for pre-processing or post-processing or anything special that needs to be considered when I want to leverage this model. But as is, we're going to point this, we're going to score this data set that's sitting inside of that data folder. It's just the simple Boston housing inference data set. So what we're predicting the median value of housing costs in Boston. And we're going to write all of those predictions just to a flat file. And last but not least, we are going to tell Drum what type of model it is, right? So is it going to be multi-class? Is it going to be binary? Is it going to be regression? Is it going to be like maybe some sort of wild unstructured model, or is it just going to be maybe anomaly detection is one that we're also going to support? And so as I'm going to execute the drum score, there are a couple additional things that you can add on. If you prefer verbosity in the logs that are going to be written to screen, you can certainly choose a verbose option. And then we can also turn logging level on to any level that we would want to pursue. But I think right now, logging level is going to be set to warning by default. And so I've gone ahead, I've executed the drum scoring routine, and I've leveraged that rf.pkl, that pickle of the random forest, and it's written all of the predictions out to disk. And I can just read those predictions in just and take a quick peek at the head. I have all of the predictions that are associated with all of the records that I asked Drum to score. I'll pause there for a second and ask, is everybody with me so far?
Yes.
Or are there any questions? I will take silence as in everybody is understanding everything I'm saying and everything's going swimmingly. So, but if it isn't, definitely feel free to interrupt.
So Tim, there is a question in the chat just around how often do people need to update their models? And then Raj said we're going to talk about this later, or do you guys have a specific section on that? Should we hold off?
We will have a specific section on that. So we're going to get through actually serving the models up via API. And then we're going to have a brief discussion about monitoring those models. And then we're going to highlight how we can hook up this open source utility with DataRobot MLOps and dive into some, details about monitoring models, data drift, service health, et cetera.
Awesome.
Cool. Thanks, Stephen. Great. So batch scoring, I do like batch scoring. I do believe it has its place. Now, what we're going to look at Drum out right now for is to be able to take our model and host it as an API endpoint, right? And we're going to go through, we're just going to be leveraging the subprocess library inside of Python to spin up our inference server. And inference here is all about the purpose of scoring data. And we'll walk through the command that we do to spin this up and how we can change it and some of the things that we can tweak and tune based on our objectives. But these libraries are all necessary for us to just be able to request predictions and then being able to consume those predictions and display them in a pandas data frame. Now, within Drum, right, we already talked about the different modes through which we can sort of serve up Drum, you know, batch, like just scoring data, servers, validation, etc. So we're going to be doing the server routine here now. And again, it's that same that we have to be able to point Drum at the model artifacts. And we're also going to provide an address where Drum can sort of spin up the process and be able to have the server setting at. So the address is just going to be nothing more than localhost port 6789. We can certainly show some performance information. We can set the logging level. We can show the stack trace if we wanted to, and we can prefer a verbose, you know, sort of display. One thing that we do have to do again, and that's all going to be a matter of telling Drum what type of model it is, right? So is it regression? Is it multi-class? Is it binary? Is it unstructured? What is it? That's really gonna tell Drum how to serve the model and how to return the predictions. Now, this command as is going to do nothing but flask to serve up the model. If I wanted to use NGINX, I would want to turn on this production flag. So this production flag is going to make sure that I'm going to use NGINX instead of flask for the server. Now, I would also want to be able to provide an argument, if I can type, of max workers. So max workers are going to be, what's the concurrency that I can expect with this? And this is going to be using uWSGI in the background. And the technical details of it, I'm not really too in the know on. And so hopefully we have another person from our team, Yakov, who's going to be joining us, and he can field like a lot of these deeper questions. But these two options right here are going to take you from going to from a Flask server, probably not one you might recommend for production, to a more robust serving mechanism through which you'll be leveraging NGINX and uWSGI in the background. And again, this is going to require you have NGINX installed, and when you're going to go through and spin this up, it's going to make a call to make sure that it can get everything up and running. But without these two arguments, right now, all we're going to be doing is leveraging just the Flask server to sort of set our model up and host it. So that's the command. And then we will execute the command in this inference server equals subprocess.popen. So that's going to set everything up, and everything will be up and everything will be running. And there's going to be a number of endpoints that the Flask server is going to expose. So it's going to expose a simple ping. We can go out and check the status of the model. There's going to be a shutdown endpoint. There's going to be a predict endpoint. And there might be a stats endpoint. I'm drawing a blank on that now. But if you are interested in learning more, definitely go out and check out the main DataRobot Drum repository. Cool. So we're going to go through and we're going to just ping the server to make sure that it is up and running. I do put like a 5-second sleep on there just to make sure I don't ping it before it has the opportunity to start up successfully. And we see that once I have pinged it, it returns the pong is actually okay. And now is when we can start getting into sending data over to our server for inference. In order to do so, I just have a simple scoring function that's going to have the URL that we're going to hit, as well as my pandas data frame just in binary, basically in the CSV stream that I'm going to send over to the prediction server and request on. So once I've executed that, I add my function in memory, and this is what's going to load the data into pandas, and then I'm going to pass that pandas data frame to my scoring function, and it's going to return the predictions associated with those records, right?
All right. Hey, Tim, we had a question, and maybe you can work this in along the way.
Yeah.
So you've shown right here, right, that you've taken a CSV and scored it, and that makes sense. What happens if people want to scale this up? So if they want to scale because they have an increasing volume, latency, how does Drum kind of affect kind of this ability to scale? Does that make sense?
I think so. And that's when I would say it all comes down to a matter of being able to leverage that NGINX server to be able to host your model. Because and then at that point, you're going to be able to control the amount of concurrency you'll expect. And then through that process, it's just a matter of being able to handle that load and being able to address the data that you're going to be seeing.
Yeah, so the hardware has to be able to handle that concurrency. And then of course, based on your model, so depending on the type of model you have, could have different memory requirements. So that's going to be another part of the equation here. If you're doing a very simple model versus if you're doing a complex deep learning model, could take more memory that you'd have to manage.
Yeah, absolutely. I did go through one of those examples in that main repository. It is Keras on GPU with Drum. So this is an example where you could set it up with NGINX and go through and really control the amount of concurrency that server is going to be able to handle. But again, too, this is one of those instances where the primary reason I set this up was I wanted to be able to leverage the GPUs for the inference. And then I wanted to be able to set up NGINX and uWSGI to be able to handle more than one request at a given instant, right? But again, you kind of have that bottleneck here because I'm just leveraging one TPU inside of Google Colab for scoring, where if I probably had a more robust setup, to to instantiate that model, it would probably be something that would be go a lot faster.
So one other question, and we have to kind of do a survey, is how do we pronounce, is it NGINX or NGINX? I don't have a definitive view. I'm not a web guy. I don't know.
I pronounce Jupiter.
It's NGINX.
It's NGINX?
Yeah.
Okay. There we go. See, we're learning something, Tim.
Yeah, like I always say, I'm like the bad person because I pronounce like Jupiter, and somebody gave me a scolding because I don't pronounce it Jupiter, and I said, "Go kick rock." No, I'm just kidding. But yeah, so NGINX, yeah. So then with this, as we've gone through and we've made predictions, really I'm just gonna go ahead and go through and terminate this server. And again, simple Flask, but if you wanna maybe an example where you're using NGINX or uWSGI, definitely go through that one Keras example that's available. Now, to get into like some of the details that, or I guess some of the points that Raj was speaking to earlier in that classic pattern of being able to have an app and instantiating your model within an app. I have an example inside of that repository too, with a really, really simple Flask app where you're going to set up two instances, two servers are going to be running, one Flask server to sort of host your model, another Flask server to sort of host your app. And whenever the app is going to be getting a record it wants to make a prediction on, it's going to be leveraging that same prediction function that we just created within our notebook, so that anytime that the app is completed, the app is filled out, then all of that data is going to be passed over to the Flask server hosting your model and asking to make a prediction on top of that. And so that means, that I can have that app up and running at all times. But if I found myself in a situation where I wanted to swap a model in for the model that's currently running, the model might be performing poorly, I can do so pretty quickly. And that's all going to come down to the power of being able to pretty much handle a good chunk of really a lot of popular machine learning frameworks that I might want to be able to toss over at Drum. And so this is going to be an instance where, just to highlight, the ways in which, or the types of models that we can handle pretty quickly, just by able to pivot and tell Drum, hey, where to look for a particular model. So all of these models are going to be doing the same thing, right? They're all going to be built on top of that Boston housing data set. They're all predicting the median housing price of a home. So all we want to do is say, hey, Drum, I don't want you to use that random forest that I built. I want you to instead, use that H2O Mojo that I exported out of open source H2O to score my models, right? And within this, the artifacts that I provide is nothing more than the zipped up Mojo that I exported from open source H2O, right? So Drum handles that, it loads it in, and then it's going to be making predictions on top of that. I can also maybe go in and do anything I've written inside of Keras. I wrote a deep neural net to do predictions on the Boston housing data set. As silly as that might sound, I can go through and I can ask, hey, Drum, leverage the Python Keras model that I wrote. And then it will go through, and logging is set to a significant amount of detail. So I get to see exactly how that model is instantiated and what's being leveraged in the background in terms of resources. And then that model is going to be making predictions. If I wanted to hot swap in an XGBoost model that I wrote, I can certainly do that as well, provided that the XGBoost package has been installed, right? Or if I even wanted to do a DataRobot Java export. So that was a model that was built inside a DataRobot and exported as a jar file that I want to serve up and I want to make predictions against. So pretty much, I scored the same data set with 5 different models with the same line of code, just a slight change in the path that I was pointing to. So now if you can imagine the ability to just change this instead of score, I'm going to use this as a server. I'm not going to have to, have a significant or a deep understanding of how to Java runtime environments in order to get that H2O Mojo up and running. Any questions or comments? Yeah, and I think the one thing that would be neat is that I'm sure that everybody's seen the Boston housing data set before. So it'd be awesome to hear any feedback if you get to kick the tires on Drum and try it out, right? Try it out with your model to see, about how you can instrument it to be making predictions. So I'm going to hand it back over to Raj, and we're going to get into some details around monitoring deployments, right? So when you actually have your model and you have that model in deployment, you should hopefully be monitoring those models and checking for performance and drift and all those other goodies that go along with the certainty that models will degrade over time. So Raj, I'll kick it back. I'll stop sharing, kick it back over to you.
We can't hear you, Raj. We can't hear you.
Yeah, you're muted.
All right, thanks, guys. Okay, so let's talk a little bit about kind of why we'd want to bother with model monitoring. So typically what happens is, right, we're getting new data coming in, we have our model set up, and then what we're going to want to do is then store the results, the predictions, and put them in a database, connect them to a web app like that. And ideally, right, everything will kind of work kind of just fine. We just hook it up and it all goes. Now, what happens though in kind of real life is that data that's coming in often changes over time. And so we talked earlier about some of the changes. Maybe there was a dramatic shift between the data that you got for training and the model. There can also be shifts like COVID, right? You think your model's going fine, but all of a sudden now the price of oil has gone negative, air travel has dropped off. These are different types of inputs that you might have in your model. And so if you want to be able to kind of sleep at night as a data scientist, you need some type of monitoring to be able to kind of identify these shifts before your model breaks. Because all of these things are going to affect the accuracy. They're going to also affect your uptime of your model if you have the wrong type of data that's going in. Okay. Oh, I thought I had a different set of slide decks. Oh, this is why. That's what I wanted, right? So things will break if your kind of data doesn't, if somebody changes, right? Another one is changes the data type for you, right? They could have changed something from a categorical to numeric. Sometimes they just change from lowercase to uppercase, decided the camel case, the variable names now, and all of a sudden your model falls down. There's so many little things. It's not often the world changing, that can break the models. And so that's why it's important to have model monitoring. And if you have, again, this is the same kind of thing where if you have just a handful of models, you have 2 or 3 models and you're doing them in batch, it's probably not that big a deal. But as soon as you start scaling up, it just gets too hard to be able to maintain and monitor all those models. And we'll talk in, are you going to show, Tim, in the dashboard, all the service health and all the different dimensions?
Yep.
Okay, right. And we'll talk about all the different dimensions and the ways you can study models. But I've known many a data scientist who has models in production at big, Fortune 500 companies, and they know their monitoring isn't that great. They know that there's a million things that could go wrong, from their data that could go wrong to IT flipping the wrong switch on a firewall that could bring down the model. So without having some type of monitoring in place, it's just really stressful to know, is your model continuing to kind of put out predictions? Because the goal is things are going to break. I mean, this is the world. Things are going to break. But ideally, you want to be able to identify this early as you can before things break. So maybe then you can intervene or find some other alternative. And so that's why we want to do model monitoring. And it's done very inconsistently, and even at the enterprises that are among the best. Often, like the most important model or two, somebody might have hand-coded their own monitoring around it, but then there's 95% of the other models that have very poor monitoring, for example. The monitoring systems are often very kind of different across different departments like that. And so it's a real mess. And I don't know, we'll see if anybody else wants to chime in on this for monitoring. But this is one of the things is, as kind of AI and ML matures, this is one of the areas where organizations are starting to invest and trying to improve it's better, because they've realized to get the value out of these models, you need to keep them up and running, and you just can't have them break. And the other thing we're going to go into a little bit is, it's also time to involve different personas than just the data scientists. In a lot of organizations right now, it's data scientists that are monitoring the models and keeping these things up and running. But you know what? Like, data scientists don't like to do that job. They want to go build models. And you have people sitting in IT whose job is to monitor infrastructure, to monitor software, that could easily add monitoring models to their portfolio. And so one of the things, a lot of this is just that transition, is moving these monitoring capabilities outside of data scientists to others. All right. So we've got the workflow here kind of in the notebook, where we're going to be able to show you how we can kind of take that model we have. We could input in one of our MLOps libraries that basically has a monitoring agent. And that monitoring agent will watch all the predictions that are coming through. There's different ways we can do it, local file systems, there's other queuing systems we can use. But then they sends that back to DataRobot, so you can get the monitoring that way. All right, Tim, I think this is, I'll show it to you. So that for those of you who haven't seen kind of how machine learning monitoring is done, this is kind of a nice tour of that to get a sense of that. All right, I can't hear you, Tim.
Sorry, yeah, I'm sorry.
No worries.
I am sharing, and I'm just getting into DataRobot right now. Yeah, so when we're going to go through this, one of the things that's going to be required to be able to actually turn on the monitoring with the model that we're going to serve up via API is going to be a DataRobot trial. So you can get a free 2-week trial to kind of explore the platform at the link provided here. Within this too, to be able to do monitoring, you're going to need Java 11 or Java 12 to be able to run everything that's going to be followed. And so that's why the colab environment was ideal, because everything is pretty much already set up and ready to go for us. So from within DataRobot, that's such a bad time for my access to be turned off, Raj. Give me 1 second here. It's just signing in. Yep. So when we're inside a DataRobot, we're going to interact with it all through API. So that means that we are going to set up a deployment through API, an external deployment. And along with that, we're going to provide some metadata around the model, as well as our model training data, so that we can leverage some pretty nice features of MLOps when we're going to want to be able to get into monitoring data drift and such. But for those of you who may have gone through and already, have a DataRobot trial account, just going to be grabbing an API key, and I'm also going to be grabbing this DataRobot MLOps agent. So I'm just going to be downloading this. I've already downloaded this ahead of time, and I've loaded this up into my colab environment right in that content folder. And we're going to be interacting with this as well as the app2 environment, leveraging my API token. So when I'm going to go through and connect, and then I'm going to go through and unzip, unpack my tarball, all I'm going to need to do is set up the agent service that's going to be running locally. So Raj talked about the idea of like having this agent service and how it's going to communicate with the model. And there's a lot of different varieties or ways that we can do this. We're simply going to be having our model, we're going to buffer data to disk, and then our agent service that's going to run, it's going to monitor that particular location that we're buffering data to. And then it will communicate all of that data back to DataRobot MLOps. You can do this buffering to disk, if you wanted to use a message server, like if you wanted to use Rabbit, or if you want to use PubSub or SQS, those are going to be supported, I think, pretty much out of the box. It's just a matter of being able to configure the agent appropriately. And so once we go through and we configure our agent, all we're going to do is set up our endpoint and our API token, and everything else by default is going to be pointing to this temp TA directory that's sitting inside of the machine's local file directory. Now, as I mentioned, Java 11 or 12 to run this. And as I'm going to execute this and I'm going to start my agent up, that agent is going to be up, it will be running, and it will be looking for listening to data at that temp TA directory. You can certainly go through and check the status of that agent, or even go in and inspect the logs to make sure that the agent service was able to connect to the platform and be able to reach it, connect, and now it's going to be ready to start sending information back to the platform. So that's all we need to do to set up our monitoring service. The next component that we need is to really to be able to register our model within DataRobot. And we're going to do so by installing the DataRobot MLOps library that was included inside of that tarball. So once I've pip installed that, just going to go through and get some of the required packages, the libraries into the namespace. And now I'm going to start to set up and provide some metadata about my model. And some of the information, just as when we were using Drum, this information is going to be necessary. I need to be able to tell DataRobot to expect, binary model, multi-class, regression, etc. And the more information I provide here, obviously, the better it's going to be. And so once I've sort of set up the model metadata, now is when I'm going to create the model package and deploy it inside a DataRobot. When I'm going to be doing this is going to take a long time. Well, not a long time. It's going to take about 5 minutes, specifically because it's going to upload all of my training data. And so this is one of the benefits of being able to have the training data available, so that now I can provide that to DataRobot MLOps. And as we're going to be scoring the model or scoring data with our model, new data, the agent service is going to send information back to MLOps, and MLOps is going to be able to go through and check data drift. How different is the data you're scoring today, different from the data on which the model was trained? And there's a lot of different metrics that we would expose, for you to sort of get that assessment of data drift. And as I'm going to go through too, data is uploading, going through and enabling data drift so that we can, monitor all of that. And at the end of this, we're just going to be provided with a model ID and a deployment ID. And then we'll be able to leverage that to go into the platform and sort of see how everything I set up within, by way of the API is going to manifest inside of the DataRobot MLOps. So, yep, that's completed. I have the data drift, the deployment ID, as well as the model ID, and I'll just print that link to screen. And now I'll go into DataRobot MLOps. And so again, all that metadata was just provided to populate all of the detail here. And given this is an external deployment, we will start capturing service health. So total number of predictions, amount of time it takes to make said predictions, as well as being able to do a data drift assessment. And at a later point, if I did have accuracy that I was going to be collecting, labels or actual values of my records, can be able to provide those back to DataRobot, so DataRobot can give me accuracy assessment of the models. And then yeah.
Hey, Tim, do you have an example where there's actually like the data drift and accuracy is filled out? Because it'd probably be useful for people to.
I do.
And so I'm not sure if everybody kind of fully knows all the pieces, so that way.
Yeah, sure. No, thanks for asking me to do that.
No worries. I know some of the people are newer to model development, and like the first piece that he was doing was service health is usually what most people would think about in terms of what you would monitor.
Yeah. So yeah, let me just back up then a little bit. So when I'm inside of the DataRobot MLOps, dashboard, my first view into this is like all of the active deployments that I currently have access to. And when we get into those active deployments, the things that we're going to be exposed first and foremost are just glimpses of the overall health of the model. And so whether or not that health is going to be defined by the service health, by the drift of the data, or even by the accuracy of the model, I can kind of cycle through and float to whatever I really want to dive into. And we do provide a really, a nice governance workflow around this. So we don't want just people going Wild West and doing model deployments. We probably would want some sort of structure or some sort of policy in place so that when Rajiv deploys a model, it can go through the proper channels to get signed off and then be able to be made live and actionable at the same time. But so where Rajiv was speaking to there was when we get into that whole idea of data drift. And so here's a housing price example that I currently have set up. And so this is going to be an interesting one because along with having my main model that's currently deployed, I have several models that are running in the background, sort of like shadow models that are seeing the data, but they're not seeing at the same time as the production model, right? Because we wouldn't want to consume resources that would be leveraged to, make predictions in real time. So these shadow models sort of sit down here, live and breathe, and see the model, see the data, and we can sort of get an assessment and do hot swaps if we want. Now, but the data drift is going to be one of the most important things because as sure as, well, as the sun will rise and set, the data in your model will probably start to look different over a given amount of time. And that's what we want to be able to expose. So with you thinking about data drift, really being able to understand how far data drifts versus how important they are to your model. And so that importance mechanism is really an importance as it would relate to the target. And on the y-axis, we lay out the drift. And so in the UI, we provide just a simple population stability. So for any one of these instances or any one of these variables where we start to see variables drifting, we're able to pull up and try to understand, well, what exactly is drifting within this? And we get that exposure just by way of a histogram of the data. So we can say, are there new levels that we're seeing that we never saw before? Has there been a fundamental shift in the distribution of the data? And all of that can manifest itself right into the UI here. And then
and I was just gonna say, right, because if you're doing this without DataRobot, right, you have to kind of manually wire that up. Like, so we heard the other example where, right, your new test data is totally different than your training data. Well, I mean, if you're building this out, you have to build some type of monitoring that looks at those distributions, compares those distributions, identifies where they're different. And this is where we get into like, how much time do data science teams want to spend building that stuff out? It's not, right? They'd rather spend their time building models and doing this. And so this is where kind of I see it, people kind of, for a few models, they'll build this stuff out, but for lots of stuff, they won't. And it's like that. But hopefully people get like why you want to be able to monitor kind of how your variables are changing over time. Does that make sense?
Yeah, so somebody brought up like a really great point, right? New levels, new levels of categorical variables that you've never seen before, and what should happen when you start to see these new levels, right? So that might be one of the first things that we start to expose within this data drift. And so if you, give me 1 second while I refresh. I hope I just didn't go into a bad deployment. That's going to be the first place where you can start to go in and see, am I seeing new levels for a given variable or something like that? And then you can actually turn on some rules in the back end, like triggers, right? That could sort of handle new levels that had never been seen before based on some rules that you would set up. You completely turn that off on me. Right?
And this is also where there was an earlier question about updating the model, like when do you update the model? And this is where you want to have ideally a quantitative basis for deciding when to update your model.
Yeah.
So if you can understand how the incoming data is changing, how the accuracy of your model is changing over time, then based on your business case, you can then decide when it makes sense to retrain it. You know, are you going to retrain it every hour, every day, every quarter, every year? You know, all of that depends on the different characteristics kind of your model. But this allows you to kind of measure that and have an understanding of when you should be able to do that.
Yeah, and then with that being said too, though, is that we can set up all sorts of notifications, and I think we currently offer integration with Slack. Is there any other messaging, communicating?
I think we have a webhook, so you can hook it into anything. So yeah, so the Bit Plumber has a great line here, right? People would not tolerate not monitoring a production database, right? Why would they tolerate not monitoring their models? It's a good question, and data scientists, I think, kind of by their profession are a bit more optimistic, right? We believe we could solve problems, and I think often data scientists like to kind of ideally think that their model is going to keep staying up. They're not from the same background as IT. I think most IT people think about the worst case because they've seen the worst case many, many times.
Mm-hmm.
So that's my pop psychology reasoning for why we have so many models without monitoring.
Well, it's hard too. But yeah.
So yeah, it's a bunch of extra work at the end of it, right? And if you're customizing it, yeah.
For sure.
All right.
So yeah,
I want to make sure we can. Oh, okay. We have another question. Oh, go ahead, Tim.
No, go ahead with the question.
Let's see. Marcus has a question, right? It's similar to how bottles might be black boxed, right? Why was it before SHAP? Yes. So there was an analogy here Marcus is making that model monitoring might have just been, just like before we didn't have the tools easily to understand what our models were doing. Maybe now with better monitoring tools, we'll start doing that. So yeah, I'm with Marcus.
Yeah, absolutely.
Okay. I know we're getting kind of near the end of time. I just want to make sure everybody's felt like they've got their questions and hopefully learned a little bit about kind of model deployment here for this.
Yeah.
So yes, I mean, I think one of the things Tim showed you was how we can kind of monitor the agents. All of that stuff is accessible via APIs, and so you can build. And so what a lot of our customers will actually use this to build continuous learning loops, where you kind of have the model trained, and then you learn, monitor the drift, and then based on that, decide when to retrain the model as well. All right.
We'll get through oh, go ahead.
So there was a question about using Drum with AWS SageMaker. I have a quick answer, but I don't know if you have an answer, Tim.
No, go for it.
Well, so it depends how you use AWS SageMaker, right? SageMaker has a lot of pieces. Some people use SageMaker to train a model in a notebook and then deploy it with SageMaker. Some people will bring a Docker container and use SageMaker to deploy that container. So what Drum is doing is, if you've already built your model, it's going to help you get that endpoint. So similar to what SageMaker will do, except you'll have the flexibility to deploy that endpoint on whatever hardware you want to. And you don't have to pay the AWS cost for doing that.
Mm-hmm.
Does that help explain the difference to it?
Yes,
okay.
Thank you.
Yes, no problem.
And you can also run and test it locally.
Yes, absolutely. Yep.
Ah, Yakov is on. Is that Yakov?
Yeah. Yes.
Nice. Very cool. So we'll go through and just add the monitoring aspect into Drum. just with a couple of additional arguments that we'll provide via the command line. We're actually going to do this by way of some environment variables that Drum will pick up on. And so to do this, it's really just a matter of telling Drum how did I configure my agent service, right? So where I was going to be buffering all of my data to disk, I need to give Drum the model ID that was registered with DataRobot, and the deployment ID that was registered with DataRobot, as well as letting Drum know that, yeah, I do want you to monitor my model. And so we are going to go ahead and spin this server back up, that Drum server, and as that's going to be picking up all the environment variables, when I'm going to start to make predictions with this, I'm going to now be registering, right, those predictions and all of the features that went along with those predictions inside of DataRobot. Again, so not a lot changes here, just from the exposure that we've had. I'm still making predictions. I'm still just kind of looking at them and still poking around. But now if I go back into DataRobot, into that deployment that I had set up, whereas before I would have had like 0 predictions made, and we'll be able to go in and actually look at some of the information. I would just pass through about 100 records. All those 100 records have been registered. It was made across one request, and I see the, some of the other statistics to go with that. And 2, now I can start to go in and explore that data drift. Now, data drift on 100 records versus the entire data set, just kind of use some caution when you're going to be interpreting this. But this is all the details or all of the information that I would be pretty interested in seeing here, right? And so in this particular instance, anybody really familiar with that Boston data set and going into PT ratio, I can see what's drifting here, or what does certainly look different. And again, I'm not going to be as worried just on 100 records, but if I was maybe getting more records and start still seeing the amount of drift manifest here, I would certainly be kind of cautious about that for sure. And that pretty much sums it up in terms of, just adding that monitoring into the mix there. And just going through and shutting down my server and stopping my instance of the monitoring agents that are currently running. And yeah, if I wanted to, I could certainly go in and expose some of the service statistics around that deployment that we were just interacting with. And all of that detail is getting retrieved from DataRobot. I would definitely invite anybody to be able to go through and explore some of the other notebooks. Like one of my favorite new additions in inside of Drum is the whole idea of unstructured mode. And so the way that we've sort of been interacting with DataRobot right now, it's been all around like, hey, I have a binary problem or a multi-class problem, or I have, a regression problem. But when we go in and we interact with Drum through unstructured mode, we can pass in anything we want basically and return anything we want. It does require you to have the responsibility to sort of know how the data is going to be going into your model and returning it appropriately, right? But other than that, pretty much the sky's the limit in terms of what you can pass to DataRobot or pass to the model being served up with Drum, and what it's going to be returning. And in the particular example I provided here, I packaged up a light gradient boosted model with a SHAP explainer. Because every time I wanted to make a prediction, I wanted to be able to return the predictions as well as the SHAP explanations that went along with that particular record. So nothing really looks any different from what we did in that previous notebook, right? I'm still spinning up Drum server, and this time my target type is going into this unstructured target type. So that means I can return anything that I want to be able to return here. And in this particular instance, I'm using Avro behind the scenes to sort of serialize the data, and I'm leveraging Avro schema just to read the data in and being able to set it up correctly so that I know when I'm going to be making my prediction request, I can take those bytes that come in and I can restructure it as my SHAP explanations for the problem, as well as the prediction that's being made. And so this is a pretty slick utility. I think this just came out within the last 2 weeks. Off, but it's pretty cool.
Yes, something like that.
Yeah, it's a good example too, because right, Marcus brought up SHAP before, so I don't know if you guys have covered that yet in your meetups, right? But the SHAP and the interpretability is always a great topic as well.
Absolutely. Are there any comments that anybody? So just a shout out for Yakov on the phone. So Yakov's one of the core contributors to Drum at DataRobot, and just an all around awesome dude. So thanks for joining, Yakov.
Thank you.
All right.
Just a general comment, Tim. This is Steve and Raj. Thank you guys for putting this together. The demonstrations that you have in the collab is awesome. Super easy to go through. Been following along, so I really appreciate it. You made it nice and easy.
Thanks, Stephen. Thanks for sure. Yeah, and the one thing, like, really to get people poking around in it, because yeah, I think it's a really great tool, right? And it really can make things a lot easier. But too, anybody that has any interesting model packages or libraries that they run into on the regular, are encouraged to make a commit on the DataRobot user models if it's something that they think a lot of people would get some usefulness out of. Very cool. Well, thanks, and everybody. And the thing about future meetups, if anybody does have any topics they'd like to present, definitely reach out to one of the organizers, and we can certainly see about getting another virtual event scheduled.